Welcome. This video is going to talk about polarity of molecules. Now, we've already talked about the polarity of bonds, and most covalent bonds are polar because unless a atom is bonded to another atom like itself, the electrons aren't going to be shared equally. But just because the bonds are polar doesn't mean that the molecule has polarity. So just like polarity on a bond means there's a positive end and a negative end, in order for a molecule to be polar, there has to be a positive end to the molecule and a negative end, or we think of it as a head and a tail. There has to be oppositely charged ends. So if a molecule has polar bonds, it may or may not be a polar molecule. It depends on how those polar bonds are arranged around the center atom. However, if a molecule has no polar bonds, then it doesn't matter what shape it has, it's going to be a nonpolar molecule. So if polar bonds are spaced equally or symmetrically around the central atom, then the charge is also going to be spaced equally around it. And there's not going to be just one positive end and one negative end. That charge is going to be spread around. There's going to be areas of positive and areas of negative, but it's going to be balanced overall. So if it's symmetrical, it's probably a nonpolar molecule because the charges are going to balance or cancel out. The exception to this is, let's say you have carbon and you've got 3 fluorine atoms bonded to it, and then the 4th atom happens to be chlorine. That's going to throw it a little out of balance and give the molecule some polarity. So when we're talking about molecules, generally we're assuming it's identical atoms bonded to the central atom. When you have different atoms, that often is going to bring in polarity. So if the polar bonds are not equally spaced, if they're asymmetrical around the central atom, then you're going to end up with a polar molecule because the charge isn't going to be balanced. You're going to tend to have a negative area and a positive end. And so what are symmetrical molecules? Well, assuming that you don't have an expanded octet, you can have linear, trigonal planar, or tetrahedral for your symmetrical molecules. And what they all have in common is they have no lone pairs on the central atom. So the bonding atoms can be equal distance apart from each other. They have the same bond angle. So that's going to give a molecule no polarity. Asymmetrical molecules, again, if we're talking just up to 4 bonding sites, not these expanded octets, would either be bent or trigonal pyramidal. And they do have one or more lone pairs on the central atom, and so that's going to give the molecule polarity. There is going to be a positive end and a negative end. So let's take a look at an example of this. It says determine if the following molecule is polar or not. And I'm going to draw this fairly quickly. I've got 4 electrons from the carbon. I've got 2 oxygen with 6 each. So when I put it on with single bonds, that's not enough. So I'm going to find out I need double bonds. 2 lone pair on the oxygen, 2 lone pair on the other oxygen. And carbon only has the 2 bonding sites. It's got 2 bonding sites with just 2 atoms attached to it, 2 bonding pair, and there are no lone pair on the carbon atom, which is the center atom. So this would be a linear molecule. So even though it has polar bonds, okay, oxygen and carbon is going to form a polar bond, but the molecule is nonpolar because there's not a definite positive end and a definite negative end. Instead, both oxygens are going to tend to pull the electrons that away. So these ends are going to be slightly negative. The center is going to be slightly positive. That is not polarity. That's a balanced charge and considered a nonpolar molecule. Just like every atom has a positive center where the nucleus is with the electrons around it, it's neutral overall because there's balance with those charges. So how about carbon monoxide? And I've got just 10 electrons to work with here. And so what you find out is you're going to need a triple bond, and you're going to have a lone pair on the carbon and a lone pair on the oxygen. Now, I deliberately included this because this is a linear molecule since there's only 2 atoms joined. But in this case, because there's only 2 and because this is a polar bond, oxygen pulls the electrons more strongly to the oxygen side. Carbon's going to have the electrons less of the time. In this case, it is a polar molecule. So I've got polar bonds, and I also have a polar molecule in this case. So linear, if there was a third oxygen on here, or I mean a second oxygen on here, a third atom like we had with CO2, in that case, that linear is going to be nonpolar. But linear gets a little tricky when it's just two atoms because the only shape two atoms can make is linear. So that could be polar or nonpolar. H2O, we've drawn this several times. We've got each hydrogen sharing one electron. Oxygen needs a complete octet of 8. So this is a bent molecule. And it's definitely polar bonds between hydrogen and oxygen. In fact, they're highly polar bonds. And in this case, the electrons are going to hang out more around the oxygen, giving it a negative end. The hydrogens are going to be slightly positive and give it a positive end down there. So this also is a polar molecule, which is what we'd expect with a bent molecule or an asymmetrical molecule. My last example, I have H2, and this one, when you draw it, it just single bonds to itself. And this is a case where you really don't even have to draw it because hydrogen can only bond to itself in a nonpolar manner. It's going to have to share them equal. So if I have a nonpolar bond, there's no need to worry about the shape. It's got to be a nonpolar molecule as well. So there's some examples of how you can evaluate both the bonds and then the molecules for polarity.